Hello everyone, so today we are going to be talking about empirical formulas. You loves ravioli, give me the formioli. That's, I need to stop saying stupid shit like that. Sorry, oh my god, I need to stop cursing. Okay. Alright, so empirical formula. So I'm gonna list out the steps that, I kind of like to do for these, and kind of like the suggested steps to make it easy. But let's talk about what an empirical formula is. It's basically the most basic / like broken down, I guess. I don't know, like most basic form of a chemical formula, I guess. Of chemical formula. So let's look at an example of like an empirical formula versus a chemical formula for something. So we're going to look at our favorite C6H12O6. And the empirical formula of that is just CH2O. The reason is because if you divide all of these by 2, or all of these by 6, this is what you're going to get. So it's basically like the most, simplified, I guess we could say. We could say this is simplified version, right? So here's the chemical formula. This is the empirical formula of it. So when we're doing empirical formula, oftentimes we are given percentages of the mass, right? So we have the full mass of something. So the mass of something is going to be 100% of the mass. But let's just say we have like the mass of something, and we find out that 46% of the mass, these are just random numbers, we're not going to actually do calculations with these. 46% of the mass is Na, and then we have another, was 44% as Cl. Calculate the empirical formula, right? That's oftentimes what we're seeing, right? So I'm going to kind of list out exactly how I do it. So first thing I always do is that I turn the percentages into grams, right? So as an example, let's say we're given 54%, or we'll do 54.1, get a decimal in there. We're literally just gonna put it into grams and make it like that. So this is where we're assuming there's 100 grams of everything added together. So that's where percentages turns into grams, because a percent times 100 is the percent, not as a percent, basically. So you turn the percentage into the grams, right? And then you do grams to moles. And this is where dimensional analysis comes in. Let's say that this is like chlorine. We do 54.1 grams of chlorine divided by 1 times, I think there's 35, right? Let's check. I always forget. 35.45. 35.45 grams of chlorine per 1 mole of chlorine. And then you find that answer there. And then from that, you're going to do that to the other percentages that you're given. But once you do that, you find the mole ratio of each. And you want to find the simplest. Keep clicking this button. The simplest whole number ratios, right? So these are the steps that I take, right? You can, I guess if you're getting the correct answer, you might be able to do this a little bit different or word it a little bit different for yourself. But I'm going to go on and do a practice now. This is one that we did in class today. So in class, he wrote that we had 29% sodium, and we had 41% sulfur, and then we had 30% oxygen. All right, so here's what I did. I turned this into grams, so I did 29 grams of sodium, 41 grams of sulfur, and 30 grams of oxygen. And then from there, I had to find the mole ratio of each, right? So we do that by, I'm going to do it over here, by taking the grams given, and we are going to divide by the grams per mole of that element, right? So sodium, I think it's, 22 point, I'm just going to write 23 grams. 23 grams of sodium. I'm going to write these at the end because I'm just going to write the computation of it first. So we get 41 grams of sulfur divided by 1 times 1 mole of S. This is Na. Sulfur, never can remember, is 32. Okay, mouse. Okay. 32 grams of sulfur, which is going to be equal to something. And then oxygen, we're looking at 30 grams of oxygen divided by 1 times 1 mole, and oxygen is 16 grams. Okay, so here's the answers that I got on my calculator. I got 1.26 moles of Na. I got 1.28 moles of sulfur, and then I got 1.875 moles of oxygen. Right, so now you're probably like, these numbers are crazy. I don't want to work with these. These are crazy. I know we have to do a million steps for these in order to get a whole number for all of these, but you don't have to, right? So what I like to do first is I like to divide all of these numbers by the lowest number. So we're going to do 1.26 divided by 1.26. Do mole Na, and then we'll do 1.28 moles of S divided by 1.26, and then we'll do 1.875 moles of oxygen divided by 1.26. Okay, so obviously this is going to be 1 mole of Na. This is going to be around 1 mole, I think. Let me actually do the calculation here, just so that we can get an exact number. All right, so we got 1.28 divided by 1.26. We get 1.02 moles of sulfur. And then over here we get 1.875. Oops, 875 divided by 1.26. And we get 1.49 moles of oxygen. Right, so now these are where things can get kind of easy to look at, right? Because you might be looking at 1.5 and you're like, oh, I can just multiply that by 2 in order to get a whole number. That's easy. So what we're going to do is we're going to multiply all of these by 2. Multiply all of these by 2. And we're going to get 2 moles of Na. We're going to get 2 moles of S. And we're going to get 3 moles of oxygen. So our answer for the empirical formula of these given percent abundance or percent weights in that compound is going to be Na2 S2 O3, and that would be your final answer there, right? So what we did, just as a review, we turned the percentages into grams. Then we found the moles by doing the grams divided by the molecular weight to find the moles of each thing. Then we divided that by the lowest number of moles present to get whole numbers. So then we got 1, 1, and a 1.5. In order to make 1.5 a whole number, we multiplied everything by 2, and we got our answer, and then we put that into the formula. All right. So now I'm going to put up a practice problem for you all to do on your own, and then I'm just going to write out the answer. This is one that he also had in his class. Let's see. All right, here it is. So we're given that carbon accounts for 48.6%, and then we have that hydrogen accounts for 8.2%. And then we have that oxygen accounts for 43.2%. So now we're going to calculate the empirical formula based off of this data, and you're going to follow those same steps as we did before. So if you guys would like to pause the video at this point and try it on your own, if not, I will be doing out the problem in 3, 2, 1. All right, so first thing we're going to do is do 48.6 grams, and then we're going to do 8.2 grams of hydrogen, sorry, and then carbon, and then oxygen is going to be 43.2 grams of oxygen. Cool, this is an H, by the way. All right, so now, next thing we're going to do is convert the grams into moles. So we have 48.6 grams of carbon times 1 mole of carbon is 12.011 grams of carbon. I'm gonna do that at the end. 8.2 grams of hydrogen divided by 1 times, apologies for the talking in the background. We're going to do 0.001 grams of hydrogen. Again, all these numbers are coming from the periodic table. I just know these off the top of my head because I've been doing this a lot. So it's grams of oxygen divided by 1 times 1 mole divided by 15.99 grams of oxygen. All right, so now let's put that into our calculators. So we get 48.6 divided by 12.011. We will get 4.05, and then 8.2 divided by 1 is just 8.2. That's not grams, that's moles. Moles of carbon, moles of hydrogen, and then oxygen is 43 point, what was that, 43.2? Yeah, 43.2, 15.99, and we will get 2.7. All right, so what I'm going to do is first I'm going to divide everything by 2.7. So we do 405 divided by 2.7, 8.2 divided by 2.7, and 2.7 divided by 2.7. I'm going to work backwards here because that one's easiest. And then 8.2 divided by 2.7, we're going to get 3.04. And then 4.05 divided by 2.7, we're going to get 1.5. So if you guys remember, we can't have something that's a half, so we have to make these all into a whole number. So I'm going to multiply this by 2 in order to make it into a whole number. And we're going to get 3, 6, it's really 6.08, but we can not account for the 08, and then this is going to be 2. So our empirical formula is going to be C3H6O2, and I'm just going to check my answer from what Professor Sherlock had, and that is the answer that he also had when he was doing this problem, so I'm going to go ahead and call that correct. So thank you all for watching, and I hope you enjoyed.